Now let's take two more drugs, C and D. And similarly, we'll do the same thing. Just like before, we gave the drug C to 3 different people and measure how long it takes to recover from that virus. And then we'll take the drug D and give it to 3 people. And we will also measure how long it took them to recover. And we find that there is a 13-hour difference. So people take drug C, need on average 13 few hours to recover than people taking drug D. This is the second hypothesis that I'm going to talk about. Now, just like before, we cannot just by one experiment conclude anything. By first experiment, we only make hypothesis. You can imagine this as a drug. Suppose if you get a machine and you take a product out of that machine and you take the sample product and measure a particular parameter or a dimension, outer diameter, inner diameter, height, weight, some parameter of that machine. And when you collect the data and you found the data, wow, it is wonderful, let us buy the machine. But you will not take a decision of buying that 1 crore machine, $1 million worth of machine, just by one experiment, right? But then when you got the preliminary data, you would say, probably this is the capability of the machine, but you need to test that and verify that, claim that this is what is the actual output of the machine. So you repeat this experiment and you find that it is almost similar to what we had done in the first experiment. But then instead of 13-hour difference, there is only 12-hour difference. So should we reject this hypothesis? Because it is 1 hour difference. And similarly, when you do it again, it is 13.5 hours difference. We are not going to reject because there is only a slight difference. The point here is that we should remember is how significant it can be, how far it can be from the initial hypothesis so that you either reject it or fail to reject it. That's the whole point. So the good news is probably we didn't mislabel the drug like we did the last time, and the differences between 3 experiments might be due to random things that we cannot control. The difference is 13-hour, 12-hour, and 13.5 hours is probably because of the random things that we could not control. Like here, people exercised and had healthy diets, and from here, these people took a longer time to recover. But regardless, the hypothesis says that drug C need 13 few hours to recover. That is what is the hypothesis. That is what is the claim that we made. And the claim would be always the first experiment that we do. If 12 hours was the first experiment, we would have put 12 hours there in the hypothesis. But when we repeated the experiment, we saw 12, which was different from this, and we saw 13.5, and 13.5 was also different from this. Now, let's be honest. The only reason that the hypothesis says 13 few hours is because that was the result from the first experiment. We could have easily put 12 or 13.5 hours in the hypothesis if we got these people to test in the first experiment. So it is just that we picked these guys and these guys gave this result. And that is why we used this information to define the hypothesis, that is the claim. So then we have 2 experiments that are not different enough to give the confidence that we should reject the hypothesis. But because there is just the data suggesting that the difference is 12 hours and 13.5 hours, and these experiments make us super confident that this hypothesis of 13 hours is okay. So whatever it is, because these results from the repeated experiments are not enough to cause us to reject the hypothesis, and because they don't convince us that the hypothesis is correct, but they don't even 100% convince us the hypothesis is correct, because there is a 1 hour difference and half an hour difference. Okay, so we cannot accept. We use the word fail to reject, because if they 100% convince, we'll accept. But in statistics, we don't use the word accept. We say we fail to reject, because though it doesn't convince us 100%, but we fail to reject the hypothesis.